Okay, this video is going to take us through the very beginning of Chapter 2, discussing variables. So page 1 of our Chapter 2 notes. And so we're going to take a look at this here on our notes here. So computer memory is the first thing we're going to discuss. And the computer memory is considered the storage space in a computer. It's considered to be the storage space in a computer. It's where data is processed. So the programs, your files, and things like that are all stored in the memory in the memory of your computer. Every computer has that, and they're stored digitally in there. And it's what allows the data, allows your programs to be run and processed, music to be played, videos to be played, etc. Now the computer memory is divided into a large number of small parts that are called cells. So if you look over here on the right, this would be an illustration of the computer memory. So it's got a bunch of cells in it, and not all of them are being used. So there's some that are empty and some that are actually being used. And so it's important to understand that those cells are there. All right, and so the data is going to be stored in those cells, and we're going to show you how in a second here. So the variables. A variable is a named storage location. A variable is the named storage location in the computer memory. Okay, it's also called a memory location. So it's a named storage location. So if you look over on the right again, you have a bunch of storage locations. At this point, none of them are named. But these are storage locations that are ready, that are currently empty. A variable is named, and so you will see how that goes. The purpose of a variable is to store data to be used later in the program. The purpose of variables is to store data that's to be used later in the program. Now, what you missed if you were absent on this day is that you missed a demonstration of variables or storage locations like cups. So if you have a cup in your kitchen, you go in there, you take one, you set it on the counter, and you pour a drink in there. You don't just pour a drink in there just to store it in there, but you store it in there, you store your drink in there, so that when you would like to take a drink, you just pick up the cup and you take a drink. So it's used later on, maybe throughout the day or whatever, but you store it to use it later. And that's what's going to happen here in our programs. We're going to store data in the cells of the storage locations of the computer memory over here, and it's going to be, we're going to store them there so that they can be used later. Naming a variable. So the way to name a variable is you start with a lowercase letter. You start with a lowercase letter. And so it's different than naming a class. When you name a class, you name it starting with a capital letter. Now the compiler does not care, so we don't call this legal and illegal. Naming a variable, what we're talking about is the conventional way to name a variable. So is what most programmers do. To distinguish the names of named constants, classes, variable names, etc., those are named differently. Now, number two is we want to use lower camel casing. Lower camel casing, and we already are familiar with camel casing, and so the camel casing, of course, is, and that we can just show an example right here. So down in here, here's the name of a variable. Now you notice it starts with a lowercase letter, and then there's 3 words in one, and each word, new word, is capitalized. The first word is not. So this is lower because it starts with the lowercase, and camel casing because every word is capitalized. It's just like the class, it uses upper camel casing, and the only difference is that the first letter is capitalized. Now we want this, in 3, we want the variable names to be as short as they can. And so that's why in this example down here, we don't spell out the entire word points. So anytime you can use an abbreviation that's easy to recognize, then you want to do that. You want to keep the variable names as short as you can and still be effective. The other thing is we want, in 4, we want them to be descriptive. We want them to describe what and relate, as we can say in here, relate to the data that's being stored. So we want it to relate to the data that's being stored. So that in here, we're talking about, this says first half points. Well, that's pretty descriptive. It tells you that we're dealing with the points and from the first half. So it's clear. You know, you can't always name it as relatable, but you try to as much as you can. Now, variable data types. So data types of variables are the data type of a variable matches the data that's being stored in the storage location. Okay, the data type of a variable matches the data being stored in its storage location. So, for example, you would use an int if you are going to store a number, an integer, which are positive and negative whole numbers. So if you're going to, in one of these storage locations, if you want to store a 3, that needs to be an int. Okay, if you're going to store a 7, that needs to be in a storage location that's configured to hold ints. So then that's the type of data. It's a data type. Double relates to decimals. So if you're going to store something like a 4.71 in a memory location, we want that to be configured to be a double. All right, and then a string refers to, and what we're already familiar with is that strings are groups of characters. So a group of characters is a string. So whenever you want to store a group of characters, like Sally, then it's going to be, its data type needs to be a string. Now, string as a data type is capitalized because it's actually also a class. And so we capitalize string. We don't capitalize int or double. So a string, capitalized, holds strings, not capitalized. And so that's what they store in there. Now, data types, though, this is the kind of the odd thing, is that data types determine the size of the cell used to store data. It determines the size of the cell, or the amount of data it can hold. It determines the amount of data that the cell can hold, or the size of the cell used to store data. And so one thing just to remember is that ints are smaller than doubles. Ints are smaller than doubles. So an int does not take as much storage space as a double. And so when you declare variables, we show here, when you declare an int, the cell size will be smaller than if you declare a double. All right, then declaring a variable is very, very important. All this stuff, this is critical to understand because this is going to relate. You're going to be using variables the entire semester, and you're going to be declaring variables the entire semester. So it's very, very important that you learn early what declaring a variable means and what a variable is. And so as we look at this, declaring a variable? Well, a declaration defines the name and data type of a variable. That's the purpose of it, is it defines the data type and the name of the variable or the storage location. And so this tells the compiler what you want to name the variable, the storage location, and what kind of data it needs to hold. So here's an example of a declaration. You're going to be writing lots of these. So notice the data type comes first. And so what happens is when the compiler sees this line of code, int first half point semicolon, it goes int, okay, I need to go pick a cell out of the computer memory. So it goes to the computer memory and it looks at it and it goes, okay, we're going to take this cell, it's going to be configured as an int, so it's going to hold whole numbers or integers, and we're going to name it first half points. So write first half, so well, you don't have to do that yet. So first half points. So etc., etc. I'm not going to write the whole thing. It's going to take forever. So that's essentially what it does in the computer memory. And so it reserves this place. So let's write down in here in number 2, what is the compiler's actions when it sees this line of code? Now I'm going to ask this question a lot of times, and it's going to be on tests and everything, because it's important you understand what the compiler does with this line of code. And so number 2, or 1A, I'm sorry. So 1A, this is what we want to write in here. Let's take a look at how we want to do this. And so we want to say, and maybe I should type this in to make it a little bit easier. Okay, so this reserves a storage location in the computer memory. So it reserves a storage location in the computer memory. So as we show here, we want it's going to go to the computer memory. It's going to reserve one of these cells. Reserves a storage location in the computer memory. Let's see if I can go down here. As an int. So if it were a double, it would make a storage location larger, so it can handle a double. But if it's an int, it's going to hold a smaller location. So as an int, and names it first half points. Okay, so these are the things that this does. It reserves a storage location in the computer memory as an int and names it first half points. And so what I need you to do is on where it's being illustrated, what you need to do is make a rectangle here. And what we're doing here, let's see, what we're doing is we're taking a this is we're going to say this is one of the cells in the computer memory. So it reserves a storage location, as I showed before. It takes one of these in the computer memory and it configures it as an int. So we would write int. Whoops, down here. And it names it first half points. So up here, just write first half points, and I'm not going to write it all out, but write first half points up here. And so now you've got this storage location that's part of the computer memory over here, and it's being reserved to eventually to store something. What this would be like doing is this would be like you taking a cup out of the cupboard and setting it on the counter and going, okay, I'm going to use this to pour my drink. You know, so you're kind of declaring that as a storage location for your drink. All right, so the next thing let's look at is another type of declaration. Now, another declaration here is that it uses, it's actually got a little bit more to it, but either declaration, the point is that a data type and a variable name is all that you need for a declaration. So here's your data type and your variable. Now, example 2, we have a data type and a variable. We also include the contents of the variable, and so, of that storage location. And so this is another declaration. So both ways. Now, so the compiler's actions described. Now, what you want to do in here is, I would suggest that all you do in here, and I'll write it in here, is that you say same as first example plus store an 8 in the memory location or the storage location. Okay, so it's the same as the first example, plus store an 8 in the memory location. So it's just adds one more step to it. So again, put in here your illustrated. You want to do this same thing, do this rectangle. You're storing it as an int, and then write the name of the title of here, or the name of the memory location, and then put an 8 inside of it. And so what happens is, that is like if you have a memory, let's say this is named points, and this is named, maybe another cell is called miles. I'm doing short ones, so it doesn't take me so long. Okay, so right here, this is an empty cell. It's a storage location, but it's an empty cell. This is an empty cell. This, however, this is a named memory location. That's what happens here, is when you declare a variable, it sets up a named memory location in the computer memory. And so here's another variable or storage location. But in this view, there's no other variable that have been declared that have taken up any space in here. All right, now this particular example, the variable is initialized. So right here we want to write initialized. Now initial, if you think about that, initial means the first letter of a name, let's say. So in other words, what's happening is the variable is given its first value at the time of declaration, of its declaration. So it's given the first value at the time of its declaration. Now this up here in the first example, you have the memory location that's been declared and reserved, but there's no value in it yet, but a value will be put into it later on. Now, initialization is a special type of assignment, and we're going to be talking about assignments next time, and that's what's happened here, is that when we go equals 8, we're saying that 8 is being stored inside this variable location. It's been initialized, it's been given its first value when we plunk that 8 right inside the storage location. So it's a special type of assignment. Now, the last thing is that we want to say is that you may declare the data type of a variable only once, and we'll illustrate that at another time. But you cannot go int first have points later on in the program, because the compiler will not like it, and we'll demonstrate that when we talk about assignments next. All right, so that's it for this page 1 of our notes.